Okay, this is a different discussion about limits. This time we don't have a graph. They're just going to give you something like this. The limit as x goes to 3 of x squared minus 9 over x plus 3. But in order for you to see how I'm going to approach this, I am going to consider what if we had this rational function, x squared minus 9 over x minus 3. If you'll recall rational functions, you would say, what's the vertical asymptotes or wholes of this function? You could factor difference of squares, x squared minus 9 into x plus 3 times x minus 3. And then you would see that this x minus 3 terms cancel. And so you would discover that there is a hole in the graph at x equals to 3. And so you are allowed to, after you've considered the holes in vertical asymptotes, to work with a simplified version of the function after you've considered that. So here's the simplified version. R of x is just equal to what's left here, x plus 3, which is simply a line. Y equals mx plus b. The slope is 1. The y-intercept is 3. So I'm just going to graph this line. 1, 2, 3. I'm going to go up 1, right 1. So this line is going to look like this. Okay, so I got to be careful. But at the value x equals to 3, at the value x equals to 3, it is got a hole in it. So I did this in marker, so it's really hard to erase. So you're going to have to just pretend like you are with me on this. Up here at 3, this has got a big open circle. Pretend like that's not there. But this is the graph of that function. Okay, so let's see. Let's see, what does this is the value of 6 right here, okay? This is the value of 6. So if, like in the last video where we had a crazy graph, and we said, what is the limit? Let's just look at this graph. What is the limit as x approaches 3 from the left? What is the limit as x approaches 3 from the right of r of x? And we'd say, okay, as we approach 3 from the left, it looks like it's headed to this big open circle, which is 6, a y value of 6. From the right, it looks like it's headed to this big open circle, which is a y value of 6. So we can say that the limit as x approaches 3 of r of x is 6. You see how that works graphically. Now, I'm going to show you how you do not have to graph the function, but figure out what's going on. If they just give you something like this, the limit as x goes to 3 of this, what you can do is just plug in this value into here. So plug in 3, and we get 3 squared minus 9 over 3 minus 3. And we get 9 minus 9 was a 0 over a 0. And this 0 over 0 is called something, it's called an indeterminate form. Now, when you're taking a limit and you get an indeterminate form, what that basically means is you need to work a little bit harder to figure out the limit. So I've run out of room, so I'm going to write this down again. The limit as x goes to 3. This is, once you say, oh, I got an indeterminate form, I cannot determine the limit yet, is kind of what that means. So sometimes you can get away with factoring, and you will learn other methods in calculus, but we're going to try to factor. See, this is difference of squares, so let's factor this. X plus 3 times x minus 3 over x minus 3. And we see that, oh, we can cancel that. So let's cancel that. And now we are left with the limit as x goes to 3 of x plus 3. And now when we plug in the 3, we do not get an indeterminate form. We get 3 plus 3, which is 6, and that is your limit. And you do not have to do all this graphing. I was just trying to explain how that works. So now, what if you have something like this? The limit as x goes to 2 of 3x squared minus x minus 10 over x minus 2. Plug in the 2. And if you get a number, like if you were to plug in 2 and you get a number like 7 or 12 or 0.5, that is your answer. That is your limit. That's no problem. Okay. But if you plug it in and you get an indeterminate form, then you got to work harder to figure out the limit. So what happens here is we have 3 times 2 squared, which is 4, minus 2 minus 10. Oops, sorry, 10. All over 2 minus 2. So we get 12 minus 12, which is 0 over 2 minus 2. Oh, we get another indeterminate form. So what that means is we have to work harder. And so, again, you will learn other things to do, but one of the tricks that you can use is to try factoring this. So let's say, what is the limit as x goes to 2, and I'm going to factor the numerator and the denominator. And so this will factor into 3x plus, no, 3x, what will this factor into? Oh, wait, maybe that won't factor. Let me just see. Maybe I gave us a bad one. Negative 30, I'll have to work harder. Negative 30, negative 1, let's see, that's a negative 6 and a positive 5, so it will factor. 3x squared minus 6, x plus 5x minus 10. Let's see, 3x, x minus 2, plus 5x minus 2, 3x plus 5, x minus 2, is that right? 5x minus 6x, okay. 3x plus 5, okay. That's what it factors into. All right, so now we get this cancellation. This is equal to the limit as x goes to 2 of 3x plus 5. Now when I plug in the 2, I get 6 plus 5. The limit is 11. All right, so that's something you can do when you just straight plug it in and you get indeterminate form.